For the second method, we call operator method. So before we go over with this technique, I got to define this new symbol for you. The capital D, when we write down dy, it means derivative of y by some um, uh, independent variable. It could be dy by dx or dy by dt or dy by du or dy. But the meanings of the capital D is means derivative of that function compared to the other function, compared to other variables. So if I write down as a d squared, what do you think? It means the second derivative of one variable to the other variable. But if I write down as a d to the power 3, it means the third derivative of variable y by x. So if I write down d to the power n, means the n derivative of y to the variable x. Now, do you think the operator d has the alternative position properties? For example, dy and yd. Is that the same? Is that equal to each other, dy and yd? No. dy is means derivative of y by something. yd is means y times derivative of 1 by, which is equal to, so it's not equal. Okay, so the position of d is important. If you write it in front of the variable or behind the variable, it's not equal. Okay, it's not equal. Now, if we have differential equation in this form, and I want to write this differential equation, in the term of the operator d. This one we call operator d. Okay. If you want to write it down in the term of operator d, I would get right? Do you agree with this? Do you agree with this? From this differential equation, if I want to write down it in the term of operator d, I would get this equation. Now, every term on the right hand side has y. Can I take y out? Because y is the times or multiply with d. Can I take it out? I can. Because every term we got y. But when I take it out, I got to take it out and put it behind the function of these lines. product of. So I can take y out. But when I take y out, I got to put y there. Can I put y up here in front of the parenthesis? Cannot. It's going to be different meaning. From this one, if I want to take y out, I've got to put y behind. Because when I type y in, y will go back to its position. You just cannot take y out and then put y up here in the front. If in the front, the meaning of this sentence change. So when you take y out, it's going to be behind the term in the parentheses. And this one, we call it PD. It's just the equation which is being a function of D. So in this case, I can write it down like this. And it said that if we want to find y, here is the method of operator method. If I want to find y, the way that we do, we just multiply both equations by 1 over PD. Now, PD and PD cancel out. So you would get y is equal to 1 over PD fx. Now, why I put 1 over PD in front of fx? Can I put 1 over PD behind fx? I can't, because with this sign, when you times this equation with 1 over PD, we put it in front of this function or behind y, at the front. So this one you got to times at the front of fx too, in order to keep the meaning of equation the same. We just cannot do this. This is what we can't do. Because the meaning is wrong. Because this one you put it in front of the function. So this side you got to put it in front of the function too. You can't just put it behind your function. Okay, so this is not right. It's got to be this way. That is the way that we are using to find y. And we call 1 over PD is inverse operator. Now, consider the function. If I have dy by dx equal to fx, this one, if I want to write down in the term of operator d, I would get, right? This one and this one has the same meaning, right? Right? Now, this one, you know the way to find the solution. The way that you find the solution of this one, you just move dx to the right-hand side of differential equation. You would get, right? And then to find the solution, you just do the integral. Then you would get y is equal to integral fx dx. And this one, if you want to find y, what do? you said that, okay, you times this differential equation with 1 over d, right? And then d and d cancel out. So you would get y is equal to 1 over d fx. But this y and this y is the same, right? It is the same meanings, but we just write it in a different form, just that. So from this, because these two are equal, then we can say that, oh, if we have the operator 1 over d times fx, the meaning of this one is equal to integral of fx dx. That is the first definition that you got to know. We are going to extend this one if I have 1 over d squared fx is equal to 1 over d times 1 over d fx. And 1 over d fx is equal to integral fx dx. Right? And then you put this definition again. 1 over d of integral fx dx is equal to integral of integral fx dx. Right? Right? It's called successive integral. So if you have 1 over d to the power n fx, you would get integral n times right? Now that is the first definition that you know. If you have 1 over d times fx, then it's equal to integral of fx dx. If you have 1 over d squared, it means you do two times of your integral successively.